Okay, cool.
Okay. I've seen in the past few days that you guys uploaded a lot of documents regarding the updates, and you condensed the reports for several weeks, but I've not had the chance to look at them. So, uh, can you give me an update of your current work?
Yes, absolutely. So, and I'll try to be as quick as possible. I mean, like as brief as possible. So basically, I built up the plot showing the rate of change and speed of and the acceleration of dropping data at different confidence levels. And we provided all the information to our domain experts. So right now, Ball is on their side, and they are exploring the data we gave them, and they are about to tell us which confidence level we are about to choose. I
Hmm.
guess it's gonna happen next week. So, okay, they are also busy, and one of the domain experts are going to India for a couple of months because they field data. It's collected in India. So, and the season is starting, let's say in May. Mm, yeah, that's the quick update for the first part of the of this research. So, in this case, we started to with the second part, the data for training model and also like the main approach. So basically, the main approach in our case is um, break uh, into two parts. So the first part is the binary classification between Hume's Warbler and others, and then and the second part, when we got the Hume's Warbler's files, then we have to classify whether it's a call or bus. So it's like just like two parts following by each other. So, and in this case, what I've done, um, we have to normalize the data and convert all the files into one format. So in this case, as we are working with LibreOsa, the audio format is WAV. I'm sorry, VAW, because that's the basic audio format for LibreOsa, and actually it is a kind of standard to work with.
WAV, right? Whoop.
W VWA. Oh, wait, 1 second, because I'm kind of I'm always WAV. Yes,
Yeah, okay, okay, okay.
WAV. Yes. I later on I can show you the code and just quickly go through. So and also we are normalizing all the data, like everything, into 16-bit depths, one mono channel, not stereo, and also as the to the frequency, it's got to be 44.1K. So it's all of them are standard for machine learning, and basically we just try like to do like everything based on these parameters for training and for prediction as well. So in our case, we have to define what is the other class. So I investigated the data set, so, and I realized, not realized, so like I just made the analysis, and the part of our data doesn't have Hume's Wolvers at all. So what I've done, let me show you the. I'm sorry, let me show you the code. It's gonna be a little bit easier if we have some visuals. Okay. Okay, cool. So that's actually like I've just put some notes here, if you can see. Okay. So that's like the files when I was just trying to see like which one to choose from. So basically WAV does the standard. So also I just put these one channel sample rate and bit depth as well just to make sure. And also, we are going to work with audio augmentation. So it is kind of the same as image augmentation,
Yeah,
but
yeah.
it's working with audio. So that's I defined the function as the properties. So this is the normalizing and correcting audio files. Uh, and this one splitting the pre-normal, no, not pre-normalized, with normalized files into 3 second chunks. So in this case, it can be like 3 seconds, 10, 5, it doesn't matter. So like, and why 3 seconds? Because we are based on BirdNet, and they are using 3 second chunks to analyze. And actually not the audio files, but the spectrograms of 3 seconds audio chunk. So processing that I've done for all the files, and I was checking out if the um, processed files are okay. So yes, we got like number of channels one, sample rate, and duration. So basically, it's all set. So about the other class, basically, I
Wait a second. Basically, so ongoing viral. Basically. Hey Henry, can you hear me?
Yes, hi.
Hey,
No
sorry
problem.
for the delay
It
for
happens.
stopping the conversation. So,
I I told you it's
where were
Friday.
we?
Okay. Okay, cool. Let me share again. Okay, so the main question was how to define the other class, and my main idea was we have a huge data in terms of field data for audio recordings, and let's split it because we have to make sure the other class somehow is similar to the all the sounds we have around when we train the data. So basically, I went through all the data and found the recordings that don't include Hume's Warbler at all, and I split them. So and basically all this data that don't have the Hume's Warbler, it can be used as the other class. So and we can train. I'm sorry, we can train the model based on this information. The question is, we have quite a lot of the samples. So in basically in the training data set, when we have Hume's Wolbers, we have three elevations: low, high, and medium. So and a low is about 50% of all the observations, and the medium and high is kind of like 25, like 20, 30. So shall I split the other class in the same proportion, like 50, 25, 25, or it doesn't matter? That's the first question. The other question is when you cut the data into 3-second chunks, so that's a huge amount of those chunks, like maybe I will say it's a little bit less than 1 million chunks. That's a lot. I mean, in our case.
Mhm.
Um, yeah, it depends on what you compare with. So, and as we have only, let's say, uh, a few hundred of Hume's Wolver chunks, how shall we work with other class? So, because a lot of data is just a noise. So, like, and my idea was we simply cluster around like clustering on the data we have right now. So we can get, like I said, like 40 clusters, 40 classes. And it doesn't care like which board is it, just classes. And then we kind of randomly, we cut off the numbers to make sure, like let's say we have 2K of the samples. And there's got to be some proportion, let's say, because like we don't need uh, some birds being like over presented in the class, like other class. But also we don't need like a lot of, uh, let's say, the wind or like some rain samples at all. So what is your recommendation based on these two questions? So the first question and the second question.
First, uh, the very first question is uh, uh, here, what you are trying to do is identifying the Hume Warbler amongst the others,
Yes,
right?
right. Yes.
But uh, are you using BirdNet outputs for this decision? I mean, to create your ground truth?
No.
This is the
So
point I didn't quote.
yeah. So let's get back to the collecting the data. Hume's Wolber sounds are not collected through the BirdNet. So they are collected through two different websites where like we know
Oh,
like
okay. So you're referring to the call versus buds here.
yes, call and pass, but that's the second part of the classification.
Okay.
Yes. So and the so like let's say the Hume's sounds we are getting from different sources than BirdNet. But the other class is from the BirdNet. It's not from the BirdNet. It's from the data field data we have right now, and
Yes.
those some recording do not have Hume's Warbler sounds based on BirdNet outcomes. So it's not like 100% they do not have, but like there is a high probability there are like very
Okay,
few
so
sounds of the Hume's
what you're
Warbler.
saying is that the BirdNet outputs aren't accurate in a lot of cases in your field data. So you need an additional model that performs binary classification of warblers versus others and outperforms BirdNet in this specific classification. Because BirdNet can give you if you give them a sample of 3 seconds, it will give you the birds singing during these 3 seconds. But if you say that in your field data you have observed that in cases where there is the bird, but BirdNet is not able to identify it, then it makes sense to have a proprietary model, I mean, a model created by us, making this classification. Otherwise, we can just rely on BirdNet, right?
Yes, absolutely right. I'm not saying BirdNet is not accurate. I'm not saying that. So like what I mean, just like we have to in some point justify if let's say the Hume's Wolbers classified audio chunks really correspond like on what we have like on a separate data set. So just a kind of like okay, we comparing it. And I'm not saying like our model is going to overperform. No, then definitely not. But we are trying to see okay, if we build up the model, will be the sounds identified by the BirdNet same identified by like I say our model. Maybe like probably our model will be less powerful and less informative, less accurate, but we have to like do like some comparison. And the second part why we have to do this model because we have to identify buzz and calls. And buzz and calls of the Hume solvers are not in the BirdNet database. So we still have to do that because we have to separate Hume's Wilbur into two classes. Is it the bus or is it the call? So we have
Okay.
to do like in any case. So just it's not like we're trying to um, uh, substitute the BirdNet right now. It's not about it.
Yeah, my question is why aren't we just taking the outputs of BirdNet? So we get from BirdNet the instances where the human leaf warbler is singing, and then we classify if it's a buzz or call. And why are we creating a new model that performs the same operations as BirdNet?
Great question. We're not sure about the accuracy of the BirdNet. So, and also like in this case, we also have to define the confidence class. Like, I'm sorry, level. Is it zero point 0.5, zero point 0.6, 0.8, zero point 0.9? We don't know. So in this case, it is a kind of empiric uh, mm, confirmation that we can classify the Hume's Wolbert. So we just don't know how we can mm, let's say rely on the BirdNet net or on the BirdNet data and which confidence level we should um, select to work with.
Yeah, okay. The main problem is that
But I
we
got a
don't.
point. Yes.
The problem is maybe that we don't have a method to quantitatively identify the performance of a model, because the same problem of a threshold that you have for BirdNet, you can probably have it also for your classification model, because you could, even with your model that outputs the probability of the
Mhm.
sample being a Warbler one, you will have a probability, and it's not guaranteed that zero point 0.5 is the correct threshold. So
Yes,
even in that case, you would have to study multiple thresholds probably to get, I mean, a higher threshold might improve precision, but decrease recall. And
yes,
so maybe the perfect threshold that we are interested in is not at 0.5, but maybe at 0.8. We don't
maybe.
know.
Yes.
Yeah, but you would have the same problem with your binary classification algorithm.
Okay, so your point is we just skip the first step and we just go like to try to identify is it a bus or call, right, on the BirdNet data. Is that what you
Yeah,
mean?
yes, I think that creating a new classifier that, I mean, what would be your ground truth for this classifier, the binary one?
Uh, the ground truth for the so basically we will I was thinking to use uh, BirdNet outcomes based on zero point 0.5 confidence level.
Okay, so in this case, you would be training a model to mimic the behavior of BirdNet. So this model will never be better than BirdNet in its predictions. You know,
No,
so
we're not
are
mimicking. We are using the BirdNet data to uh, see how our outcome is mm, good or bad comparing with a BirdNet. So like we're using them as a ground truth. Okay, so like zero point 0.5 confidence, we got that many Hume's Warbers, and we see like uh, comparing their data with our data, how good we are or how bad we are.
okay, but your model, the classification model, would be trained on labels provided by BirdNet, right?
No,
Ah, okay. So,
no, we
uh,
we we're not using BirdNet labels at all.
okay. So, what are your labels for the classification model?
Okay, so the labels for the classification model, we have Hume's Warbler that those labels are from Xenocanto and iNaturalist. And basically, BirdNet is also using those files as well. So like, and the labels for we are labeling other class using our field data. So BirdNet doesn't have this data at all. So it is the field data we collected in India. So
But
yes,
your field data, are you sure it doesn't contain the Warbler?
um, I believe it can have a few of them, but the BirdNet based, but the recording uh, based on the BirdNet outcome with confidence level zero point 0.5 don't have Hume's Warbler. Probably they still have some, but very few. Because the
Mm,
BirdNet didn't classify the Hume's Warbler at all in those recordings.
yeah, yeah, but uh,
I'm not sure. Yes, that definitely. I cannot say like I'm definitely sure like there is no Hume's Warbler in those recordings. No, I cannot say so because I
yeah,
don't know how accurate the BirdNet is. Yes.
the problem is that any reviewer of the paper would
Okay.
complain that you are training a model that will be necessarily based on labels provided by the model you are comparing to, because
Okay, I got it.
so it's like you're using a teacher that so you can never overcome your teacher, you know, unless you consider other types of sources, which Xenocanto might be one of them. But actually, if you are able to build a test set, maybe uh, you can use the test set to evaluate BirdNet. So to evaluate the threshold and the heuristics on BirdNet, maybe you can use your own defined test set, maybe performing the augmentations on the audios from Xenocanto and verifying that BirdNet is still able to identify the samples as Warbler, for example. But probably now the most important task is, given that we have a network which identifies the Warbler, we I think it's better now to focus on the buds versus call behavior
Okay,
so that
okay,
we
got
can
yes.
proceed faster.
Okay, okay, let's do that. Absolutely. Let's do that. Definitely we can do that. Yeah. So just keep this mm, step. Um, yeah, but in let's say yeah, let's do this step. And if I have some questions about the first step, I will just ask in chat. So yes, okay, perfect.
Yeah,
Yes,
yeah,
let's
sure,
do.
sure, sure,
Yes.
sure. Okay, sounds good.
And also I have one question. When we do the binary classification, let's say the so like we have to augment the labels for the bus and call, right? So like we do the like we just increase them like the total number. And what will be the number of the both bus and call kind of perfect, kind of good to make the binary? I mean, it's kind of a stupid question, right? Because you can't define as the data being good or bad. Like the more the better, yes. But like let's say like uh we have like 200 files of a call and like 100 of a bus, mm, and we're doing the augmentation, right? So like what will be your idea about like the number of total original and augmented files?
I think I think the problem of identifying bots versus calls should be pretty simple. So maybe we can start by simply annotating. I mean, I don't think you can have a ground truth from Xenocanto, so you will have to manually annotate this.
We done and manually, definitely. So we listen
Yes.
to make to the every file. We've done it manually, definitely. Yes, and we
Yeah.
label it like annotated manually.
Yeah. So I think that having starting from 100 buds and 100 calls is okay.
Okay.
And we can split this data in a stratified way. The important now is to have a balanced data set. So 50% buds and 50% call.
Yes.
And you can split it in training and test. The important
Yes.
is that you perform the augmentations just on the, you are taking this data from the field data, right?
Now for the bus and call is from Xenocanto and a naturalist. So it doesn't have any field data at all.
Hmm. It would be great actually to annotate some field data. Maybe just 30 buds and 30 calls to begin with, but it's so that you have a real world test set,
Okay.
because probably I expect that from if you use Xenocanto and you get data from Xenocanto to train and test your models, you will probably have 95% F1 scores. Okay. But then if you test your models on field data, you would probably see a huge drop in performance. So we need to make sure that our model that we build with Xenocanto is generalizable on real world data.
That's a good advice. So let me ask you, if we get if we label some data from the field data, right? Some buzz and call from field data, shall we use those recordings in the whole data set as like for training and test split or not? Or we just like we go, let's say like we get that recording, we just take the buzz and calls out from it, We add it to our training data, and that's it. And we're not using that recording at all. Or we
Uh,
have to
let,
use it.
let's proceed step by step. So the first step is getting your training and test data from Xenocanto in a balanced matter. Okay, so you can even start building your classification models with this data.
Okay.
Okay. In the meantime, let's annotate some data from the field data. And the first objective should be understanding how your model is generalizable to this data. Okay. So if we
Okay.
get 95% performance on field data with our model, we are good. We are fine. So we have a model that will work well in real world scenarios. So we don't have any kind of problems. But otherwise, we will probably have to include some real samples in our dataset to make it more generalizable. So it's something that we will decide later on.
Okay. 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 Good. Good. Sounds good to me. Perfect. Yeah. Let's do step by step. Perfect.
Yep.
And I guess that's the time.
Thank you so much.
Thank you, Marco.
Have a good weekend.
You too. You too. Happy Friday. Bye bye.
Bye bye.